All right, welcome back. In this section, we're going to look at how we can solve quadratic equations. And this is a method that we can use pretty much in every situation. Though sometimes factoring might be easier, or using the square root property might be easier, the principal square root property. But the quadratic formula is actually something we can always use to solve pretty much every quadratic equation. So, how do we find solutions for quadratic equations that aren't factorable? This is especially where we, really want to use something that's helpful to us, because if we can't factor it, and it doesn't really work with the getting x isolated onto one side and being able to use the square root property or principle to solve it, we need another method. And we're not going to go into, in this lecture, how we come up with this equation. We come up with it by taking this equation and completing the square within it. So if you're familiar with that process, taking this general equation where, if you remember, a is the coefficient of the x squared variable, b we consider the coefficient of the x to the 1 variable, or just x variable, and c is the constant. If we can put it into this form where it's solved for 0, we can identify those three coefficients, a, b, and c. We can plug those numbers directly into this working formula here. We can actually find the solutions that way. So that makes it really nice. All we have to do is identify those three numbers and plug them in. But we do want to, you can see it does get a little complicated there, so we want to be careful about how we plug it in and make sure we take our time and not try to rush through it too much. So let's take a look at that with a couple of examples. So I've left the quadratic formula up here for our reference, and then I've got two different equations we're going to work through on this one. And I actually used very easy. In fact, we could solve these by factoring. So I set us up here for some easy solutions here. In other words, ones that work out really nicely, just so we can get started. So now I want to point out a couple of principles you want to follow when you're plugging things in. Number one is always rewrite it using parentheses where the variables are that you're substituting for. So I've got b squared, so I'm going to put parentheses squared minus 4, and then a and c. And then we divide it by 2a. So I'm just going to put parentheses where my numbers are going to go. And now we're going to plug in the numbers. For this first equation, we see that there's no number here in front of x. At least it's not written, so we always assume that's a 1. B is going to be positive 10, and C is going to be 9. So plugging these in, I'm going to use a different color, we see negative B. This is the one that you need to be always cognizant of, because B can be positive or negative. And so when we see a negative in front of a variable like that in a formula, really you want to interpret that as being the opposite sign of B, right? The negative, or the opposite of whatever B is. And that's what needs to be here. So when you plug it in, just make sure that you have the opposite of whatever the value of B is. In this case, B is 10, so when I plug this in, positive 10, I'm going to get negative 10. Because the negative, or the opposite of 10, is negative 10. All right, also my b goes here, so I have 10 there. B squared minus 4a is 1, and c is 9. And on the bottom, I have 2 times a, and a was 1. Okay, so all I did was I plugged the values into those parentheses, and the outcome is going to be what we're looking at here. So that does give me negative 10, which, looking at my final outcome there, is what I wanted, the opposite of b. b was positive 10, we end up with negative 10 out there. And then here I've got 10 squared. Well, 10 squared is 100. And then we're subtracting 4 times 1 times 9. So 4 times 1 is 4, and 4 times 9 is 36. So that's 100 minus 36. So this is going to be positive or negative square root of 64. 100 minus 36. And then we're going to divide that by 2. So I always like to kind of figure out what's going underneath the, this b squared minus 4ac, what that becomes, and then just plug in that result underneath it in my next writing. Because that kind of usually involves 2 steps, right? So if I can kind of just figure out what's going to go underneath the radical, that's helpful. And square root of 64 is a perfect square, so that's negative 10 plus and minus 8 over 2. Now, if you were plugging these into your calculator, you would want to put parentheses around that top thing. In other words, you want to go negative 10 plus 8 first in your calculator, so you'd want to put parentheses around that and then hit divided by 2. In this one, it works out pretty nice because you know negative 10 plus 8 is negative 2, and negative 2 divided by positive 2 is negative 1. And negative 10 minus 8 is negative 18, and negative 18 divided by positive 2 is negative 9. So we have 2 solutions for this particular equation. Negative 1 and negative 9 are the 2 values of x that are my solutions for that equation. Now let's go to the next one. Now you'll notice in my previous one that this was already solved for 0. In this one, we don't have it solved for 0. We have it solved or equal to 24. So we want to rewrite that. We want to subtract 24 to the other side. So I have it x squared minus 5x minus 24 equal to 0. And so my a, b, and c are identified here as a is equal to 1, b is equal to negative 5, and c is equal to negative 24. So let's go ahead. I'm going to rewrite the quadratic formula here. Negative b plus and minus the square root of b squared, so parentheses squared, minus 4 parentheses, and all divided. Notice that division goes under the whole thing. 2 times a, so 2 parentheses. Okay, so b in this case is 5, so I'm going to negative 5, so I'm going to plug that in there. And then that's negative 5 squared. And a is 1, and c is negative 24. And then a is 1. Okay. So let's simplify this. Notice that with the opposite or the negative of negative 5. So b was negative, and with my formula it's negative b, so the negative of negative 5 is positive 5. So look how that worked out to be. It ended up being the opposite sign of b. In this case, b was positive 5, so in the final count, it ended up being, b was negative 5, so in the final count, it ended up being positive 5. And then let's go ahead and let's unpack what we have underneath here. Now, negative 5 in parentheses squared, I'm going to just write this up here. Negative 5 in parentheses squared is positive 25. But had we not had those parentheses there, if you type a non-parentheses negative 5 squared, it actually is negative 25. So again, you don't want to, what's plugged into your calculator, if you put those parentheses or don't put them, negative 5 squared without the parentheses is actually negative 25. That's what your calculator will do, which in turn is going to give you the wrong answer. So again, this is one of the main reasons why you always want to put parentheses before you, when you're plugging in things. Because even if you're using your calculator, you may end up getting the wrong square there if you don't have the parentheses. So anyway, 25 minus, and notice that if I think of this as negative 4, so negative 4 times 1 is still negative 4. And I'm going to just get my pointer here. So if we think of this as negative 4, this is negative 4 times positive, which is still negative 4, and then negative 4 times negative 24. That now would become positive. So in the previous one, we had negative 4 times 1, which is negative 4, and then negative 4 times 9, which is also still negative. So this stayed a subtraction. It stayed minus 36. Or if you think of it covering up this and thinking of it as just a subtraction, and then 4 times 1 times 9, well, that's 36, so we had a subtraction of 36. But here, if I thought of this as a subtraction, I have a subtraction of something negative, because 24 times positive 4 is negative 96, so that's minus a negative, which ends up becoming plus positive. So the general ideas here is if A or B alone, I'm going to go back here, if A or B, if either of these two is negative, this is going to become plus. But if either of these two, if they're both positive or they're both negative, it's going to stay a subtraction. But here, only one of them was negative, so this becomes a plus. So plus, because it becomes subtraction of a negative, 96. Is that right? Yeah. So 25 plus 96 gives me 121. So I have 5 plus and minus the square root of 121. You can see why I tried to do all that stuff kind of off to the side there to get that right result underneath the radical, and 2 times 1 is 2. 121 is a perfect square, so I end up with 5 plus and minus 11 over 2, which I told you these are going to work out to be nice. 5 plus 11 is 16, and 16 divided by 2 is 8, and 5 minus 11 is negative 6 divided by 2, which is negative 3. So these are my two solutions for those equations. All right, a couple more examples here. And oops, I'm just going to put this up here. A is equal to 6 in this case, B is equal to negative 1, and C is equal to negative 1. Notice that I'm always taking the symbol that's in front of the term as the sign of my A, B, or C, because remember the general equation was ax squared plus bx plus c equal to 0. So in other words, in the general equation, it's always plus. So if there's a subtraction here, it would have to be a plus negative, right? Because plus negative is the same as subtraction. Adding a negative is the same as subtracting a positive. So the long and short of it is there, we want to think of the coefficients there as negative if there is a subtraction in front of that, positive if there's not. All right, so rewriting the quadratic formula here, I'm going to go the opposite of b, plus and minus the square root, parentheses squared, minus 4 parenthesis, all divided by 2 times a, so 2 parentheses. And plugging in my values here, I've got negative b, so negative 1, and then we have negative 1 squared minus 4 times a, which is 6, times c, which is negative 1, and then over 2a, which is 6. All right, let's simplify this out. We know that the opposite of negative 1, or the negative of negative 1, is positive 1, so I have 1 plus and minus. And then let's unpack what we have underneath here. Negative 1 squared is 1, minus, here we have 1 of the 2 is negative, So that becomes a subtraction of a negative, or you can think of it as minus 4 times minus 1 here, which will become positive. So this is going to become plus 24, which is 25. And you like that, and that's over 2 times 6, which is 12. So simplifying this down, square root of 25, that's nice and square rootable. It's a perfect square. That gives me 1 plus and minus 5 over 12. So 1 plus 5 is 6 over 12, which is 1/2. And 1 minus 5 is negative 4 over 12, which is negative 1/3. So x is equal to 1/2 positive and negative 1/3. Okay, I'm going to erase a little bit of this so we can do our next one over here. But you saw how these became what they were here. Okay, for my next one, we've got some much larger numbers here. I've got 12, 23, and 24. If I can, I'm always going to look to see if I can factor out something, because 12 and 24, you could start to think, well, maybe there's something factorable here. But 23 is not a factor of any of them. They don't have any common factors, because 23 is prime. So I can't reduce my my A, B, or C's, because they're pretty big here. So at any rate, I just wanted to kind of point that out, that if you can factor it out, something out, then you can reduce the value of A, B, and C without affecting what the actual answers are. Okay, A, B, C. A is equal to 12, B is equal to negative 23, and C is equal to negative 24. So, big numbers here. Let's plug it in. Again, parentheses, negative, parentheses, plus and minus square root, parentheses, squared minus 4, parenthesis, parenthesis, all over 2 parentheses. Give yourself room. Use that scratch paper to the best of your abilities. Let's go ahead and plug those in now. So negative 23 is my B. And that's negative 23 squared is 4 times A, which is 12, and B, which is negative 24, over 2 times A, which is 12. Yay, some fun numbers to work with here. Pay it no mind. We are going to get through this. So, negative 23 squared, we know, becomes positive 529. So I'm going to put that up here, 529. And we have minus and then 1 negative, so that's going to become plus 4 times 12 times 24, which is 1,152. Adding these two things together, we get 1,681. Now, of course, the first thing I'm going to check is, hey, did I get lucky here? Is this 1681 a perfect square? Probably won't be most of the time. But if it is, that's going to make it a whole lot easier for me. And it is. Actually, the square root of this, square root of 1681 is 41, which is nice. When I go to simplify this, on the bottom I have 24, 2 times 12. So that becomes 23 plus and minus 41, all over 24. Now, if it isn't, we're going to look at an example of that on the next one. Then we can simplify it using, reducing that square root. That's why we spent some time doing that on the last section. All right, so 23 plus 41 is 64. So this gives me 64 over 24, which I don't think it goes into it evenly. It does not. but we can reduce it. 63 over 24, let's see. 6, well, that would be 32 over 12, which you can keep going there. It would be 16 over 6, so half and half. I'll do that one more time. 8/3. So 8/3 is one of my results, and 23 minus 41 is 18. Well, negative 18. So negative 18 over 24. We can divide that by 2. That would be negative 9/12, which is still reducible. 3 goes into both of those. So negative 3/4. So my two solutions for x are 8/3 positive and negative 3/4. Again, we could have found those using factoring in this case, but in a lot of times in regular outcomes, we won't necessarily get something that's factorable. In this case it was, but we can always also find it using the quadratic formula. Okay, my last examples here for my quadratics, where we have ax squared plus bx plus c equal to 0. Identifying a, b, and c. In this first one, we see a is equal to 1, b is equal to 3, and c is equal to negative 1. So let's go ahead and unpack this and rewrite negative parenthesis plus and minus square root parenthesis squared minus 4 parenthesis parenthesis. So plugging these in, that's 3. Actually, let's put it in a different color so it kind of contrasts a little bit. And that goes here, 2. Oops, I forgot my denominator. How did I forget that? Okay, over 2 times a, so 2 parentheses. And then a was equal to 1 and c was equal to negative 1. So we'll put 1 here as well. So this reduces down to negative 3 plus and minus. Let's go ahead and figure out what's up here. This is 9 minus, and then again we have one of the two being negative. So this is going to become minus a negative, or just plus 4. Okay, which is 13. So I have plus and minus square root of 13. 13 is not square rootable. And in fact, that's its simplest form right there. And this is all over 2. Now, if 13 was square rootable, I could maybe simplify this down a bit. But it's not. And I can't really add these without turning that square root of 13 into an approximation, right? Actually doing an approximation of square root of 13, I would get, well, what is square root of 13? It's about, I'm going to write this down here, square root of 13 is approximately 3.606, rounded to the third decimal place. Or probably more, we could just say 3.61. Now, I could use that, and we will here in a second, but as an exact answer, there's 2 answers that I have here. Negative 3 plus the square root of 13 over 2. And notice that over 2 is both the top and the bottom are on that fraction, and then negative 3 minus the square root of 13 over 2. Now, if you wanted to type this into your calculator, you can do that. Just make sure you put this top part in parentheses, because your calculator will want to do the division first unless you put parentheses around that top. In other words, it'll divide only the second number that you enter by 2 rather than both the negative 3 and the square root of 13. And we want actually that sum or that difference to be divided. So let's go negative 3 plus square root of 13, and then divide that by 2. Now you can always hit enter after the addition there, and that's one way to do it. So the approximate solutions, these would be my exact. The approximate means we rounded the square root. One of them is 0.303, and then -3 minus the square root of 13 divided by 2, -3.303. Those are my two approximate and exact solutions. Notice that these are approximate because I had to round them. And whenever we round, it becomes a slightly different answer. Okay, let's look at our last problem here, where I've discerned A to be 1, B equal to -6, and C to be 11. We'll write out this negative parenthesis plus and minus square root parenthesis squared minus 4 parenthesis. And okay, so then we see B is equal to -6, so that's going to go here and here. And I did this again, or I didn't finish this off. Oops. Let's go ahead and finish that off. That's an important part of this. All over 2 times A, which is 1. So I've already plugged that in there. This is A2, so 1. And then my C was 11, so we're going to put that there. And actually, let's put these in green so we see those being plugged in. Okay. All right, let's do what we do and unpack this thing. So -6, we know that's 6. And I'm having trouble sticking with my colors here. So 6 plus and minus square root. Let's figure this out. -6 squared is 36. Now we're subtracting, and it's going to stay a subtraction because A and C are both the same size. They're signs. They're both negative, and if they're both positive or they're both negative, which in this case they're both positive, it's going to stay a subtraction. So that becomes a subtraction of 44. Well, 36 minus 44 is -8. And then we have that over 2. Now the problem we have here is that we have a negative result under a square root. And we cannot take the square root of negative numbers. So what that tells me about my solutions here is that I don't have any real number solutions. In other words, I have imaginary solutions. Remember that whenever we had negatives under the square root, we could take that out as an I. We're not going to get too into that, but we'd say it's an imaginary root multiplied by +8 over 2, because I is equal to the square root of -1. Now, you may not be familiar with the imaginary root. That's no big deal. There are roots. They're just not real. So typically what we would say here is that there is no real solution in this case. Whenever we have negatives under the square root, this is how we describe the solutions. We can go further, be a little more detailed, and say that they are quote-unquote imaginary by taking out the negative and writing it as an I in front of that root. Or we can just leave it as the statement, no real solutions. That is how we can use the quadratic formula to find the solutions of quadratic equations. Good luck as you work on this tonight.